A bicycle rolls down a ramp from an initial height of 5.15 meters, as shown in the diagram below. The speed, s, of the bicycle in meters per second, when it reaches the end of the ramp, is given by s of theta is the square root of 101 sine theta take away cos theta divided by sine theta, where theta in radians is the ramp angle shown in the diagram, which is just here. Determine the speed of the bicycle at the end of the ramp if the ramp angle is 45 degrees. Okay, so we don't really need to change that to radians. Sine of 45 degrees is root 2 over 2. We only have sine and cos in the formula, so that's why we don't need to change. So, well, we could call it pi by 4 if you want, but it's going to be the square root of 101 root 2 on 2, take away root 2 on 2, or divided by root 2 on 2, which is going to be the square root of 100 root 2 on 2 divided by root 2 on 2. The root 2 on 2's cancel, so that's just going to be root 100, which is 10, so it's just going to be 10 meters per second. Okay, determine d theta of 101 sine theta minus cos theta over sine theta and simplify your answer. Well, this is a quotient. U is 101 sine theta minus cos theta, and V is sine theta. So du d theta is going to be 101 cos theta plus sine theta, because when you differentiate cos you get negative sine, and dv d theta is going to be cos theta. So the differential is going to be v du d theta. So that is sine theta times 101 cos theta plus sine theta. Take away u dv d theta, which is cos theta, 101 sine theta minus cos theta, all divided by v squared, which is sine squared theta. Now I think we might want to try and simplify this. So that's going to be 101 sine theta cos theta plus sine squared theta. Take away 101 sine theta cos theta plus cos squared theta all over sine squared theta, and we can see that that and that are going to go. Sine squared plus cos squared is 1, so it's going to be 1 over sine squared theta. Hence show that ds d theta is 1 over 2 sine squared theta times the square root of sine theta over 101 sine theta minus cos theta. Now let's remember that the s was the square root of 101 sine theta minus cos theta over sine theta, which we could write as 101 sine theta minus cos theta over sine theta to the power a half. And so ds d theta would be 1/2 101 sine theta minus cos theta over sine theta to the negative a half. Then using the chain rule, we have to multiply by the differential of the inside function, which is what we got up here. So that will be 1 over sine squared theta, and then just bring that over to there. Remember, we're multiplying all this together. And that is going to give me sine theta over 101 sine theta minus cos theta to the half. Think about what the negative does with a fraction. And then that is 1 over 2 sine squared theta times the square root of sine theta over 101 sine theta minus cos theta as required. Use the increments formula to estimate the change in S if the ramp angle is changed from 45 to 46. So, delta S is going to be ds d theta delta theta. Now, when the theta is 45, we worked out in part 1 that S was equal to 10. That means that this part of the formula, this part here, is going to be 1 over 10. Now, what about this bit? That's going to be 1 over 2 sine squared pi by 4. Now we know that sine of pi by 4 is root 2 on 2. So if we square that, we're going to get 2 on 4, which is a half. So that is 2 times a half, which is 1. And then the delta theta, well, we have to be in radians. It's 1 degree, which is equal to pi on 180. So it is just going to be 1/10. All of that's going to become 1 as we discussed. And so that is going to be pi on 1,800 centimeters. Correction, I just looked back at the units. S is a speed and it's in meters per second.